Hello and welcome to next episode of 2D top-down game tutorial in Unreal Engine 5, and in this one we will implement DamageSystem and HealthBar. After this episode we will be able to attack the skeleton and see the health on the HealthBar and kill it. So at first let's switch to the content folder and create new folder for our DamageSystem, which we will call DamageSystem. In this folder we will create new interface which will be used for all the items which can be damageable. So right click there, search for the interface, click on the blueprint interface and call it I_damageable. We can now open the interface and rename the default new function to take damage, and this will be the function we will call when the damageable object takes a damage. It will have two inputs. The first one will be called caused by, and the type of this input will be actor, and it's the object reference, and this will be the actor which caused the damage. The another one will be the amount, and the type will be the float, and it will define how much damage was taken. And there will be one output which is the damage taken, and it will be boolean, and it will simply define if the damage was taken or not, in case the damage was, for example, blocked or something like that. So that's all for the interface, and now we will create the blueprint component, and the blueprint component will be used to extend any actor where we want to count the damage. So right click on some empty space, select blueprint class, and there we will search for actor component. And we can name the blueprint class as BPC DamageSystem. We can now open this blueprint and we will start adding some basic variables there. The first one will be called health, and the type will be float, and it will be the current health of our actor. Next we will create the max health, and the type will also be a float, and it will be the maximum health of our character. And the last variable will be isThat variable, and it will be the boolean, and it will be true when the character or the actor is dead. Click on the max health, and in the right menu we should set the default value of max health to some number like 100. We can always change it and make it different for each enemy, but some default value is nice. Now it's time to implement the take damage function, so let's create a new function and call it take damage. At first we want to check whether the actor is dead, because if it's dead we don't want to take any damage, so drag and drop the isThat variable there and create branch from it. Don't forget to connect it to the take damage input, and in the true part of a branch we simply want to return from this function, so add return node. Now I noticed that we haven't set any variables for our take damage function, so let's do that now. They will be the same variables as we did for our interface, so there will be amount of type float, then there will be the caused by of type actor and the object reference, and the output variable will be damage taken, and it will be a boolean. And for our return node we will keep the damage taken unchecked, because if the character is dead the damage was not taken. Next we have to compute the new health of the character, so let's get the health variable and use it subtract action. And as another variable we will use the amount from the take damage input. We can also spend some time here to make the actions and lines nicer. We also have to handle the situation where the amount of damage is bigger than the current health, so basically the new health shouldn't be negative. So let's use the clump action and use the 0 as a minimum value and the max health as a max value. And again we can shuffle things around to make them nicer. Next we have to update the health value, so drag and drop the health value and use the set health, and simply connect the return value of the clamp to the set action. Next we have to check if the character is dead, so let's use the less or equal action for the health and add new branch there. And in the true part of this branch we will set the isThat variable to true, so let's make a line there and search for the set isThat action and mark the checkbox as a true. And this should be the end of our function, so we will add the return node, and this time in the return node we will check the damage taken, because the damage was indeed taken, and we can connect it to that set action and also to the false part of a branch. To test this code we can add two print strings here, so draw a line from the false part of a branch and add print string there, and as a value we will use the current health, so connect the health to the int string. And we will do the same for setIsDead action. So let's draw a line from the set output and add the print string and print the dead string there. Now we have to add this newly created DamageSystem component to the base enemy class. So let's open the base enemy blueprint from the characters folder and click the add button and search for the BPC DamageSystem and add it there. And because the enemy is damageable, we also have to click the class settings and add the iDamageable interface to the implemented interfaces. Once we do that, the take damage function appears in the interfaces section on the left side. So let's double click on it and we will simply call our BPC DamageSystem take damage here. So right click and search for the take damage and call the one from the BPC DamageSystem. And now we have to connect all these things together. So let's make some space there and connect the take damage input to the take damage from BPC DamageSystem and also connect the output node. And we also have to connect all the variables together. Now we have to call this take damage function from the AN hit animation notifier, because every time there is some hit, we need to take a damage. So let's remove that debug print string we have there, and instead we will call the take damage using the interface, and the target will be the array element, basically the actor we hit. This animation notifier is called for the actor which did the attack, so the caused by can be connected to the get owning actor. And for now we will just use the number 25 for the amount, but in the future it can be different based on the character attacking. One thing we forgot to do is setting the health in the DamageSystem to the max health at the begin play. So let's go back to the DamageSystem and click on the event begin play. And here we will simply set the health variable and use the get max health as a value for this health variable and connect it to the event begin play. And now everything should be ready to test it for the first time. So let's compile it and try running the game, and if we try to attack the skeleton, we will see that the health is printed, and when it goes to 0, the death string is printed. As a next thing, we can handle the death animation, so let's get back to the DamageSystem blueprint. And there we will open the take damage function, and we will start by removing the print string from the true part of the branch where we set the death value. And instead of this print string, we will create new event dispatcher. The event dispatcher allows us to create custom event and trigger it, and there can be some other code listening for this event and do some action in the other blueprint. We will call this event onThat. We can now drag and drop this onThat event and call it from the code, from the true part of the branch. And now any actor can listen on this event and do some code in its blueprint. So let's go to the base enemy and open the event graph. In the event graph, we will drag and drop the BPC DamageSystem and call its bind event to onThat. Then we will draw a line from the event and call the create event. And now we have to create a function which will be called. So on the left menu, create new function and call it handle that. Now go back to the event graph and in the create event, select the handle that function there. Now we also have to call the bind event from the event begin play. So now when the onThat is triggered in the DamageSystem, we call the handle that function. In the handle that function, we want to jump to the death animation state, so the death animation is played. So in order to do that, we need to drag and drop the paperset the animation to the screen and call its anim instance. In the anim instance, we will call the jump to node and we will move things around so they do not overlap. And we will check what is the name in the state machine for our death animation. So let's open the animation blueprint skeleton. And in the state machine, we will check the locomotion and we see that the jump node is called death. So we can go back to the base enemy. And for the jump node, we will use the death string. Now we also have to call the jump to node from the health death function. And we can try playing the game. And when we kill the skeleton, we should see the death animation played. I also think we don't need the yellow box anymore. So we can go to the animation hit and remove the draw debug box from the calls. Next thing we can implement is the HealthBar widget. So let's get to the DamageSystem folder and create new widget, like widget blueprint. And in the next dialog, choose the user widget and hit this select. We will call this widget WB_HealthBar, and we can now open it and add some components there. The first component to add will be the size box, so we can define the size of the health bar. So drag and drop it there, and we will override the width and height. And for the width we will use 100 pixels and 15 pixels for height. As in the previous episodes, we have to change the fill screen to desired on screen to actually see the proper size of the widget. And then we can search for the progress bar component and drag and drop it to the size box. We will be changing the progress bar value from the blueprint, so let's rename it to health so we can access it nicely. And we can also change the color from the blue one to the red one, which is better for health. So that's all for the widget, and now we have to add it to base enemy. So let's open the base enemy and add a new widget there, and we will call it HealthBar. In the right menu, we will choose the widget class and we will search for our HealthBar widget. You can see that the HealthBar is huge, so we have to make it smaller. So on the right menu, we will search for the draw size and change the X to 100 pixels and Y to 15 pixels. We also want the HealthBar to be above the skeleton, so let's move it up above the skeleton's head, and we also have to rotate it so it's visible from the top down. We can also switch from the perspective mode to the top mode, so we can precisely move the HealthBar to the right position. Then we need to change the collision presets from the UI to no collision, otherwise our character would collide with this health bar. And we are done now, and we can run the game, and we should see the health bar in the game. Now we have to update the health bar from the damage system. So let's switch to the damage system and let's add the health bar as a new variable which we call health bar. And the type of this variable will be WB health bar object reference. We will create new function called UpdateHealthBar, and in this function we will actually run the code to update the health bar when needed. The health bar needs percentage, so we have to compute the percentage of a health. So we will get the health and max health, and we will use the save divide action to divide these two values. Now we have to update the progress bar, but at first we have to get it. So let's get the health bar. From the health bar, we will get the health value, which is actually our progress bar in that widget. And we will use the set percent action to update the progress bar. And the in percent will be set to the return value of that save divide. And we also have to call the set percent from the update health bar. Now we also have to call this update health bar function from the take damage. So let's open the take damage function. And instead of that last print string we have there, we will call the update health bar. And we actually have to call it from both branches, from both true and false branch, because we want to update it no matter if the character is dead or not as a result of this take damage action. The last function we need here is the function to set the health bar variable. So let's add a new function called set health bar. And the input for this function will be called health bar, and the type will be WB_HealthBar object reference. We will simply drag and drop the health bar variable here and use the set action to set the health bar and call it from the set health bar input. And we will also call the update health bar once we set this variable. Now we also have to call this set health bar function from the base enemy where the health bar widget actually is created. So let's go there, and at the event begin play, simply call the set health bar action. We will do that by drag and dropping the damage system there, and from the damage system simply call the set health bar. And as a health bar input, we will use the health bar widget. So drag and drop the health bar widget there, and we have to use its get widget action, which will actually return the widget stored inside that widget component. And we have to cast it to the WB health bar, because otherwise it's like widget without any certain type. Now call that cast action before the set health bar, and we will use the SWB health bar output as an input for that set health bar. We can now try running the game, and if we start it, we can see that the health bar is red, meaning full, and it reacts on the attacks. It would actually be nice if the health bar would be invisible before we start attacking and after the enemy is dead. So let's try to do that. Let's switch to the damage system and open the UpdateHealthBar function. At first we will check whether the health bar value is less or equal 0.99. That would mean that some damage has been done to the character. Then we will check if the character is still alive. It means that it's not dead, so we will get the dead value and negate it using the not action. And we will combine these both conditions using the AND operator. And if both conditions are true, it means that there is some damage done, but the character is not dead, and therefore we will add a branch, and in the true part of this branch we will show the health bar, otherwise we will make it invisible. So get the health bar variable and call its set visibility action, and keep the invisibility set to visible and call it from the true part of a branch. And we can copy paste this code and set the visibility to hidden and call it from the false part of a branch. Now if we run the game, we can see that the health bar is not there. If we attack the enemy, it appears, and if the enemy is dead, it disappears, and this is exactly what we want. The last thing we can improve is the health bar fill type, so it's filled from the right to left. So for that we will open the widget health bar and search for the fill type in the progress section and change it to right to left. And now we can try running the game again, and we can see the fill type changed as expected. So that's all for this episode. I hope you liked it, and in the next one we will work on the AI for the enemy. We will teach the enemy how to move around and how to chase us when we are close to it. Please subscribe if you like this series, and see you next time. Bye.